All right, here we go. 36, which table represents y as a function of x? All right, this is the classic math problem. They always ask something like this. What's a function? What's not a function? So a function, definition of this is each input has at most, so no more than, one output. Each input has at most one output. Now, a hint for this here, I kind of tell my students to look for this. This means no repeated x values. So if like your x value repeats, that means you probably have two different outputs corresponding to that same input. So I'll kind of talk about what that means here, just looking at some of these. So we are looking at for which one of these does not have any repeated x values. So like for example here, on f, if I can zoom in, that'd be lovely. It's just not working. All right, here we go. On f right here, notice they have -5 and -5 right there. That x value repeats. Notice here that -5 goes to -5 and then also to +5. Right, so that means you have a repeated x value. That means that x value of -5 has two different output values. So this is not a function right there because of that repeated y value. Now you could also do this by kind of looking at the sketch of the graph, and then it's called the vertical line test when you're looking at a graph. So if you had like -5, 1, 2, 3, 4, 5, and then down 5 and then up 5 for one of them right there, you'd have this thing called the vertical line test. And if a vertical line crosses through 2 points at the same time, then it's not a function. It's a visual way of doing all this here. Now I wouldn't actually hit any other points, I don't think. -2, so there's a point right there, and then you had -3 and then -2 right there. So your vertical lines would be good on everything except right here. There's your problem right there because of the repeated x values. So we can go look here. H has got some repeated x values. J definitely has a lot of repeated x values. If you look at G, kind of looks like it, but you got 6, -6, 8, and -8 right there. And none of those x values would repeat. If you graph it, you'd be able to get a bunch of vertical lines going through. Now, if y repeats, that's perfectly fine. Doesn't matter. You see how we got 6, and then nope, I thought it was repeated. And here, there's one. Yeah, so like on H there's one where your y values repeat. That's perfectly fine. We are specifically looking at your x values there. So no repeated x values or the vertical line test. So don't forget to look at that. All right, 37, which statement about this polynomial 2x squared minus 3x minus 5 is true. So you got zeros and then you got factors there. So I guess we'll try and factor this thing. All right, so my way I teach it, kind of different depending on your teacher. We take these two values, a times c, that's going to be -10. So I need factors of -10 that add to -3. So I think the factors that'll work out there for that, I think we can go -5 and +2. Okay, and then there's this weird step after this here. You got to go back and divide by your a coefficient. Your a coefficient is 2. And then the way I teach it here, it's got this weird step where you swing around the denominator if it doesn't reduce. And then you reduce down if you can. You can do 2/2, so that reduces to x plus 1. And there's, 100 different examples on how to factor. So if you're not sure, if you're not very good at factoring, go ahead and check the internet for that. There's a bunch of stuff on YouTube, and like Khan Academy has a bunch of good stuff on that. So that matches up with, obviously, see, that's the only one where the factors match up. Now the zeros are very similar here. The zeros are kind of like your x-intercepts. And to find your x-intercepts, you want to set this thing equal to 0 and solve. So I'm going to take it a step further just to verify to you what the x-intercepts or what the solutions or what the zeros are. Now we kind of talked about this I think a couple of videos ago. If you have something times something else equals 0, we can split it up into multiple cases. Like say for example a times b equals 0. Well, either that a part is equal to 0, or your second case would be the b part equals 0. So I call it split and solve. You split it up, you solve them out individually. So this first one, you need to add the 5, then divide by 2. So I think that's 5 halves right there. This other one here, you can do it one step. It's a -1. So that definitely matches our answer right there. 5 halves and negative. Yeah, so I don't even think any of the other answers match up with that. So that's all you can do there. Another way you could do that is use Desmos, right? Use Desmos, graph that thing, check the x-intercepts, and since there aren't any that actually repeat, then this one should work out there. So that one rather straightforward here. What do we got here? The graph shows the volume of a gas sample. It changes as the temperature changes and the pressure remains constant. Okay, which of these best represents the rate of change? Right? They like throwing these rate of change problems right here. In middle school, they called it slope. In high school, they're going to use rate of change a lot more, but basically it's slope. So you can do your slope formula, y2 minus y1 over x2 minus x1. Now this one's a little tricky to do because they don't actually give us points here, so we're going to have to get kind of close to our answer here. So you got to just kind of be kind of careful on some of these. So what I like to do is try to find something very close to a nice point here. So I'm kind of seeing something right here that kind of looks pretty good, and then I guess I'm trying to find some nice points here. That kind of looks like a decent one, and maybe one of our answer choices will be kind of close. So notice here that starts at 20, so I think these are going in ones. 21, 22, 23, 24, 25. So yeah, each of those ticks are going by 1. I think each of these ticks are going by 5. 5, 10, 15, 20. Yeah, so each of the ticks on the x-axis are going by 5. So this one's going up to, whoa, and then over, I guess, not just 5. I guess it's going over up 2 units there, and then 5, 10, 15, 20, 25. So 2 over 25. So I guess now it's trying to figure out which one of these is closest to that. Now 7 over 100, definitely not. Actually, that could be kind of close there. I guess, yeah, F could be a good option there. 7 over 100. Let me see what the answer choice here is. Actually, I have 1 over 12 is the answer there. So, I'm trying to think of a good way to explain why. So I guess it's kind of like going up 1 and over 12. I guess you could kind of figure that out here. 5, 10, and then not quite 15 right there. So I guess you could kind of say that on that one. So, 2 over 25, I guess if you reduce it, you could say it's like 1 over, 12.5. So it's kind of close to what we got there. So that's probably, that one's going to be the closest one there on that answer choice there. It's definitely not H. It's definitely not, up 22 and 2/5 and over 1 there. So it's probably, going to be that up 1 over 12. That'll probably be the closest. Hopefully they write this question or a question like this a little bit better to where they actually give you some points that come out real clean. If they give you points that come out real clean, it should be easy. So I would just go with your gut there, or the bit closest one. I think it's 1 over 12. So yeah, just go with that one there. So, anyways. Next one here, what is the solution to the system of equations? All right, now this one here, this is a very good Desmos problem. So actually I'm going to start out this question here with Desmos. Let me flip to my paper copy here so I can copy it down easy because this one's kind of complex. So we'll go to Desmos, go to test mode, clear out my previous graphs. So we're just trying to see where this thing crosses. Looks like we got 10x minus y, and then equals 53. And also you have here y equals, and then the second one, we're going to have to put all this stuff in the numerator, so you have to start it out with some parentheses. So negative 13x plus 92, close parentheses, and then divide that by 2. So kind of a trick one right here. So we need to go see where these cross here. Desmos, what I like about it here is you just click on where they cross, and that's your solution. So apparently x is 6 and then the y is 7. Now as far as doing that by hand, that gets really tricky here on this one. What I would do, I guess I would go ahead and do substitution here. So all of this is equal to y, so what I need to do here is I need to plug that whole expression in for y. So this one's going to get kind of tricky here. So it's going to be 10x minus parentheses all of this. Close parentheses equals 53. I'm going to probably need a calculator, so let me cue that up. Okay, now the key thing here, this negative out in front, it's kind of like saying negative 1, and I'm going to distribute that just to the numerator. So it's going to be kind of tricky here, so I'm going to say that's 10x, that's going to be plus 13x minus 92, and then you're going to divide this whole thing here by regular 2, and then equals 53. Now, I don't want to deal with this giant nasty fraction here. So what I'm going to do next here is actually multiply both sides of the equation by 2. Now, when I multiply this fraction here by 2, I multiplied by 2 so the 2's would cancel out. So those would cancel out, and you have 13x minus 92. But don't forget to go back and distribute to the 10x. So that'll be 20x. Then I guess you got plus all that stuff there. 53 times 2 should be something like 106. Alright, now we're ready to go as far as solving. Now this is just a regular solving problem with some larger numbers here. So I think you get 33x. If you do 92 plus 106, I guess you get 198. And hopefully when we divide, hopefully we get 6. So 198 divided by 6 on my calculator, I got x is equal to 33. Or I'm sorry, not 33. I got x is equal to 6 there. So that kind of came out decently there at the end. That one's really hard to do by hand. It's legitimately not an easy question. Another way around it, maybe you could have multiplied both sides of your equation by 2 from the very beginning. That might have helped out there on that one. And then you could have used elimination. Actually, probably be a hair easier. Might even show you guys. Yeah, I'm going to go ahead and show you with elimination just for kicks. But anyways, once you get x equals 6, then it's easy from there. Then just go plug it back into one of your equations. And I think that first one's a little bit easier. So you'll go 10 times 6 minus y equals 53. So essentially that's like 60 minus something equals 53. And once you solve it out, you'll get y equals 7. Now, actually, I'm going to show you here with elimination. Maybe it'll actually be a little bit easier here. So elimination is essentially what you're trying to do is add two equations and try and make it to where you can get the x's or the y's to cancel out. So actually I'm going to write this weird equation above. So what we're going to do here on this one is I'm going to multiply both sides by 2, kind of like what we did before. And actually here, I need to draw that differently here. So the right-hand side, when you multiply by 2, that's actually going to cancel out the 2's. That's why I'm multiplying by 2 in the first place. You're going to get negative 13x, and I guess plus 92. You don't actually distribute the 2 because the 2's cancel out. Then over here on this side, you're going to get 2y. Okay, another step I want to do here, so I want to get it in standard form, just like this other equation. So I'm going to add 13x. So I'm going to write this here, 13x plus 2y, and then equals 92. Now I want to think, so those are my two equations there. I just kind of manipulated some of them. So now what I want to do here is I want to add these two equations to where either the x's will cancel out and the y's will cancel out. Now the y's will almost cancel out. You have 2y and negative y, so you'll get 1y when you add them. So what I'm going to do here in this case is I'm going to multiply both sides, or multiply everything here by 2. So I'll get you 20x minus 2y, and then equals, I guess, 106. Okay, and then I'm going to rewrite this thing down here. So this one's still not really that quick. And you're going to see a lot of similarities with the numbers. Notice you get 33x again. Notice the y's cancel out. Notice you get 198. So then, of course, once you divide, you should get x is equal to 6. And then just follow the steps that we did down here to go get your y value. Either way, not easy by hand. So this is going to be one of those problems really good with Desmos there. I would even start this question without, or with Desmos. I wouldn't even try to do this one here by hand. So that one's kind of a tricky one there. Good news is number 40 is not too bad here. The table contains some points on the graph of an exponential function. They even told us, they gifted us that it was exponential. So it's going to look like this right here. Y equals some type of a value times your growth or decay factor, and then raised to x. Okay, a is always your starting amount, or what's going on at 0. It's kind of like your y-intercept. That should narrow down your answers right away. That's definitely going to have to be h. All right, now let's talk about where the 4 part comes from. The 4 comes from each step, looks like you're multiplying by 4. So you're repeating that. Multiply by 4, multiply by 4, multiply by 4, multiple times there. So I don't even see another answer with the 0.0625. So we don't have to worry about that. You definitely don't start at 0.5. I mean, yeah, none of these are even close to it. All right. Also, another way you could do this here, this would be a good one for your graphing calculator. If you take this and type this into Y1 into, like that top left button on your TI 84 or 83 calculators, type in these equations and then go and look at which one of these has the matching table. That's what I would go and do there, just to go double check. It'd be a quick way to do it. So that is it there for these questions.